topic for lesson 3.3 is solving equations by using multiplication and division. We'll solve equations using multiplication and learn how to solve equations by using division. They ask the question, how can equations be used to find how long it takes light to reach Earth? It may look like all 7 stars in the Big Dipper are the same distance from Earth, but in fact they are not. The diagram shows the distance between each star and Earth. Light travels at a rate of about 5,870,000,000,000 miles per year. In general, the rate at which something travels times time equals the distance. So that's an equation we'll use a lot. Rate times time equals distance. The following equation can be used to find the time it takes light to reach Earth from the closest star in the Big Dipper. And so they substituted in the rate, which is always true for the speed of light, times time equals the distance that they have found. And then we could, get rid of a bunch of those zeros to make it a more manageable equation. That's not so bad. So if we divide by, let's see, that'd be 1,000 million. Okay, if we divide both sides by a billion, we would get something easier to deal with, and then we could divide both sides by 5,870, and we would find the time. The multiplication property of equality states, if an equation is true and each side is multiplied by the same number, the resulting equation is true. So using symbols for any numbers, A, B, and C, if A equals B, then if we multiply both sides by C, AC equals BC. And it looks pretty simple with numbers. If we start off with 6 equals 6, we can multiply both sides by 2, and we get 12 equals 12. If 9 equals 9, which it does, we can multiply both sides by -3 and still get a true statement there. -27 equals -27. If we start off with a statement, this is getting tricky, 10 equals 10, we can multiply both sides by 1/2, and we get 5 equals 5. That's going to tie in nicely to our other property in this lesson. For the first example, they asked us to solve s divided by 12 equals 3/4. And I intentionally wrote that divided by because I want to undo dividing with multiplying. So I'm going to multiply both sides by 12. And we could write 12 as 12 over 1 since that's already a fraction. The 12s cancel there, and I can cancel 4 in that 12. So when we multiply, we have 3 times 3 is 9. And yeah, if we multiplied the denominators, we'd have 1. So 9 divided by 1 is going to be 9. And then it reminds us to check our solution, which is always a good idea. So if I substitute 9 back in where s was, so 9 over 12, and reduce by 3, I do get 3/4. So my check step worked, and 9 is the correct solution. For our second example, they gave us 2 mixed numbers and asked us to solve. So to change -3 3/8 to an improper fraction, okay, remember to change a mixed number to an improper fraction. We're going to take 8 times the -3 be -24, and then add another 3 to that. Well, we should just not worry about the -8 times 3 is 24, plus 3 is 27, and it's negative, but we don't care. And then 5 times 1 is 5, plus 4 is 9. And then we just need to multiply. We're going to use that multiplicative inverse trick we learned earlier. We're going to multiply both sides times the multiplicative inverse, or reciprocal, of the coefficient of k. So we multiply both sides by -8 over 27. And of course, we cancel, which is wonderful. And cancel the 9 and the 27, and that's all I can cancel there. So I have k equals 1 times -8 would be -8, and 5 times 3 is 15. Then check your solution. So if we start off with our original equation, -3 3/8, and we take it times our k we found was -8/15. We still have to change the -3 3/8 to an improper fraction, which is still going to be 27/8. And it was negative times -8/15. And this time when I cancel, and I can divide by 3, I get negative times negative is positive, so I get 9/5, which would be the same as 1 4/5. So my check step worked, and I'm happy. And so I know that -8/15 is the correct solution. I am liking example 3, short and sweet. Solve. -75 equals -15b. So to undo divide by -15, the inverse or opposite operation would be to divide both sides by -15. So negative divided by negative is going to be a positive. And 75 divided by 15 comes out beautifully as 5. And I should still do my check step. So if I take -15 times 5, positive times a negative is a negative, and 15 times 5 is 75. My check step worked. I am happy. So 5 was the correct solution. On July 20th, 1969, Neil Armstrong stepped on the surface of the moon. On the moon, his suit and life support backpacks weighed about 33 pounds. What would be the weight of Neil Armstrong's suit and life support backpack on Mars if 3 times the Mars weight equals the Earth weight? We could simplify the question and just what we need to know is 3 times the weight on Mars equals the weight on Earth. And we could let W equal the weight on Mars. So 3 times the weight on Mars equals the weight on Earth, which translates into 3 times W equals the weight on Earth was, in the problem, 198. Fortunately, we're using the problem they solved in the student edition, but we'll survive. Let's write it a little bit closer together. So 3W equals 198. So to undo, divide by 3, I'm going to undo multiply by 3 with dividing by 3. So I get W equals 66 pounds. Now, when we were talking about solving that original problem they asked about the distance of the nearest star in the Big Dipper to the Earth, I used a division. The division property of equality says if an equation is true and each side is divided by the same non-zero number, the resulting equation is true. So using symbols for any numbers a, b, and c, where c does not equal to 0, if a equals b, then a divided by c equals b divided by c. What do you suppose the reason is for this c cannot equal business 0? What happens if c equals 0? Can we divide by 0? How does that work? Okay, so these work. 15 divided by 3 is 5. If 28 equals 28, which it does, and we divide both sides by -7, we get -4 on both sides. Here we go, straight into the point. Solve 11W equals 143, then check your solution. So to undo times 11, which is what 11W means, I'm going to divide both sides of the equation by 11, and I get W equals 143 divided by 11 is 13, and that's a quick, easy check. All I have to do is take 11 times 13, and using a calculator or a little arithmetic, I get 143. My check step worked, so W is 13 is correct. Here's another gloriously simple problem. If -8x equals 96, find x, or solve. So to undo divide times -8, I'm going to divide both sides by -8. And we know that a positive divided by a negative is a negative. So 96 divided by -8 is -12. And once again, we want to practice checking our solution. So -8 times what I found x to equal, -12. Negative times negative is a positive, and 8 times 12 we know is 96. My check step worked. X is -12 is the correct solution. For our seventh and final example, they ask us to write an equation for the problem, then solve. Negative 14 times the number equals 24. Well, that translates quite nicely into an equation. Negative 14 times n equals 224. And we don't usually in algebra write the times sign. We would prefer to write just negative 14n equals 224. So to undo multiply by negative 14, I'm going to divide both sides of the equation by negative 14. So I get n equals positive divided by negative is a negative, and I have negative 16. And once again, we want to check to make sure our solution works. So I'm going to go back to my equation. I'm going to substitute negative 16 in place of n. And negative times negative is a positive. 14 times 16 is, in fact, 224. A check step worked. It's a happy day. Wrapping it all up, when we solve equations by using multiplication or division, we're going to use either the multiplication property of equality. So for any numbers a, b, and c, if a equals b, then a times c equals b times c. Or the division property of equality. For any numbers a, b, and c, where c does not equal 0, if a equals b, then a divided by c equals b divided by c.